Good morning, students. Today I am going to explain one practical for you, and you listen very carefully. If you have any query, you write in the chat box. Okay, right. Now, today's practical is that we are going to verify the Ohm's law and we are going to draw the graph between the potential difference and current. Okay, right. For that, what we have to do? What is Ohm's law? Can anyone write in the chat box what is Ohm's law? Write in the chat box what is Ohm's law. Is it clear? Is the screen is appearing now? Yes or no? Is it clear, students? Screen is appearing now? Now see here. First, what we are going to do here, aim to determine the resistance per centimeter of a given wire by plotting a graph potential difference versus current. Okay, what we are going to do here, we are going to find the resistance by length. Resistance per centimeter means resistance by length of a wire by plotting the graph between the potential difference and current. Can anyone write in the chart box what is Ohm's law? What is Ohm's law? Write in the chat box. Yes, Savan. Current is directly proportional to potential difference. When the proportionality is removed, we will get some constant. What is the name of that one? What is the name of that one? Okay, you see here, this is the to determine the resistance per centimeter. I am going to verify the Ohm's law and I am going to find out the resistance per centimeter. You see here, according to Ohm's law, the current flowing through a conductor is directly proportional to the current flowing through the conductor is directly proportional to the potential difference. Okay, current proportional to potential difference. That is the Ohm's law. Potential difference proportional to current. When the proportionality is removed, we will get a constant. The constant name is capital R. V is the potential difference, I is the current. Current proportional to potential difference. If current potential difference increases, current also increases. When the proportionality is removed, we will get a constant that is capital R. Okay, right. And now you see here, R is a proportionality constant. It is known as resistance of the conductor. R formula from above equation is R is equal to V by I. R on what factors depends? Resistance depends upon the nature of material, temperature, dimensions of a conductor. Okay, right. And what is the unit of the resistance? SI unit of the resistance is, write in the chat box, students. What is the unit of the resistance? Okay, resistance unit is ohm. Resistance unit is ohm. Okay, R resistance formula is V by I. According to this, volt by ampere also we can write. Okay, right. Resistance depends upon some factors. We know that resistance directly proportional to length. Resistance depends upon the length of the wire. R proportional to L. R inversely proportional to area. When the proportionality is removed, we will get a constant R is equal to rho L by A. Or we can also denote with S here. R is equal to S L by A, where S is called as the resistivity. Where S is called as the resistivity or the specific resistance. Here S or rho. This some in some books it will be denoted with S. In some books it is denoted with rho. Here resistance directly proportional to length and resistance also inversely proportional to area. When we combine them, we will get this formula. Okay, this is the formula for the resistance. Resistance proportional to length, resistance inversely proportional to area. From that resistance formula is R is equal to rho L by A. From this rho formula, if you want to write, what is rho here? Rho is the resistivity or the specific resistance. Rho is the specific resistance or the resistivity. It depends upon the nature of material. Resistivity formula from above equation is, you take A to left side, RA by L you will get. And A is the area of cross section of the wire. Area of cross section of the wire is pi r square. Then we write as R into pi r square by L. This is the formula for the resistivity. Now let us go for the activity at here, how to do this one. Okay, right. And now for the purpose, what are the operators required at here? You see here, I'm going to explain it here. So are you looking the operator set here? This is one battery. It is called as the battery. It is the battery. Okay, and this is the, you follow the cursor. This is the rheostat. Rheostat. What is the use of the battery? The battery is used to produce the power supply. Right. That means it creates the potential difference. Some potential difference is given it here. Some, it is the battery, it supplies the current or the power. Okay, this is the rheostat. On this, some nichrome wire is wounded at here. Okay, this act as a variable resistor. This is the variable resistor. Variable resistor means its resistance will be changes by sliding this one. You can move this, and by that we can change the resistance of this one. And this is the digital ammeter. Digital ammeter is used to measure the current, and this is the digital voltmeter. It is used to measure the potential difference. And this is a wire piece, manganese wire. Its resistance I want to find out. And this is said to be plug key. Plug key, when we close this plug, then current passes, otherwise not passes. These are the operators required to perform the experiment to verify the Ohm's law. First apparatus is battery. It supplies the power or the current or the potential difference. And to measure the current, we use the ammeter. To measure the potential difference, we use the voltmeter. And to stop or to start the current, we use the plug key. To change the resistance in the circuit, we use the rheostat. This is the rheostat. And this wire is the small piece in the white color it is appearing, and that is called as wire. That wire resistance I am going to find out experimentally, right? Then how to do the experiment, that I am going to explain. First, you select some length of the wire. Okay, select the material. Wire material I am taking as nichrome. Okay, right, or anything you can take. Copper wire you can take, no problem. Okay, this is a copper wire. Okay, this is a copper wire. When we change the we select the material, when you will change select the material, at the moment the color is changing. It's aluminum in white color. Okay, iron somewhat this color. Okay, and we can find out the any, you can take any material. Okay, right, I'm going to find out the copper resistance. For that I am selecting the copper material at here. Okay, you take the length of the wire as some length of the wire is 50 centimeter. I am taking it here. You may take anything, 60 or anything you can take. Okay, 75 centimeter length of the wire I am taking, and the diameter of the wire I am taking is you may take anything. Diameter of the wire is 0.5. I am taking millimeters. Okay, resistance of the rheostat we can change later also, right? Now what we have to do, we have to do the connection set here. For that, there should be diagram is there for the Ohm's law. From the battery positive terminal to, we have to connect to the positive terminal of ammeter. Okay, and negative terminal to the voltmeter positive, and voltmeter negative to rheostat upper end, rheostat lower end to plug key, and plug key second end connected to negative terminal. This is the circuit diagram. And across the voltmeter, we can connect the resistance wire also. This is a circuit diagram, you should remember. First, battery positive to ammeter positive we can connect. Then for the purpose, you see here, this is the battery, it supplies the current. It has two terminals. This red color terminal is the positive, black color one is the negative. And from the red color one, we have to take a wire. Further, what we have to do it here, we have to click on this. We have to click on this. and we have to take a wire, drag it, and we can keep it here. Okay, we connected the from positive terminal of the battery to the positive terminal of ammeter. You see the circuit diagram. Positive terminal of battery to positive terminal of ammeter. Okay, right. Next, what we have to do? Next, what we have to do? You see carefully. Negative terminal of the ammeter to voltmeter positive. Right. Okay. You see here. Negative terminal of ammeter is black one. Red one is the positive. Black one is negative. Negative should be connected to. We have to take the wire right here, and that should be connected to positive terminal of the voltmeter, right? Okay, connected. You see the circuit diagram. Negative terminal of ammeter to positive terminal of voltmeter completed, and voltmeter negative to rheostat upper end we have to connect. Voltmeter negative to negative means voltmeter black one. Okay, voltmeter black one we have to connect now. Voltmeter black one, from that where we have to take, we have to click it here. Okay, we have to click and we have to connect at the upper end like this. And then after that, okay, next what we have to do? You see here, rheostat upper end we connected, and rheostat lower end we have to connect it to plug key. Rheostat lower end is connected to plug key. This is the lower end of the rheostat. It is connected to plug key. RH means rheostat means it is a variable resistor. This is the lower end. We have to connect to the plug key. Okay, you see here we connected to plug key, and the plug key other end is connected to negative terminal of battery. The last one is that the plug negative terminal of battery connected to plug key another one, right? Completed. And from here you start, click on here, click here. Okay, then after that drag and left where you want to keep, then the connection is completed, right? After that one more wire is this wire we have to connect. Where we have to connect this wire? You see the circuit diagram. Okay, this is the capital R is the unknown resistance. This wire resistance I want to find out. Okay, that wire I am selecting as copper wire resistance I want to find out. Then for that, across the voltmeter we have to connect the resistance. For this resistance wire is connected to positive terminal of voltmeter, and this resistance wire is connected to negative terminal of voltmeter. One end connected to positive and other end is connected to voltmeter negative. Okay, you take the wire from here and connect like this. Okay, right, across the voltmeter we connected the resistance wire. This wire resistance I want to find out. Okay, that is connected across the voltmeter. Its resistance formula we know already, right? According to Ohm's law, R is equal to V by I. We will use potential difference is measured by this voltmeter, current is measured by ammeter. When you find out the V by I, we will get the resistance of the wire. For that, first I will keep the rheostat resistance as how much I am keeping it here. Rheostat, you can keep some resistance at here. That rheostat resistance of the rheostat is now 15, or anything you can take. Okay, or 8 or 15. Okay, 15 I am taking. Then after that, place the plug key at here. Plug key, you just click on the plug and keep inside. Okay, you see here this plug key is not closed. That's why ammeter is showing 0 reading and voltmeter is also showing 0 reading, because ammeter and voltmeter both are this circuit is open circuit. That's why they are not showing any reading. We have to close the plug key. Right? If you have any query, you write in the chat box. I closed it here. After closing, what happening it here? This ammeter is showing some reading and voltmeter is showing some reading. You find the ratio between them. Okay, you find the ratio between them. Voltmeter reading by ammeter reading. It will give the resistance of this wire, right? Okay, like this we can find out the resistance, and then after that you change the resistance of the rheostat. When ammeter is reading is decreasing, voltmeter reading is also decreasing, because both will be changes by you take the different values of, you can keep the rheostat at somewhere. Okay, first I am keeping the like this, rheostat 1 ohm. Is it appearing, students? Okay, now you here in the down there is some table is there. In the table you have to note the voltmeter reading and current ammeter reading, then you have to divide the both of them, you will get the resistance. Like this you have to change the just rheostat. In the practical you have to move this one actually. When we move this, you see here I am moving this upper one. When you move this, then automatically the resistance in the wire changes. Okay, when the resistance changes it here, you see here I am moving this side. Okay, when you will move this, the resistance will be changes in the circuit. When the resistance changes, the voltmeter reading is changing and the ammeter reading is changing. Then you note the voltmeter reading and ammeter reading for the various values of the rheostat. Then you find the R by I, and you also draw the graph between the V and I. You will get a straight line. Okay, right. This is about practical. If you have any query, write in the chat box. First, I will tell the readings also. Okay, first you keep it here somewhere. Okay, now the voltmeter reading and ammeter reading, what happening? Right, we are keeping the resistor at 1 ohm. Show the result. Show the result. Okay, you note it here. Voltmeter reading you note it here, 9.397. 9.397. And ammeter reading you noted here. Ammeter reading how much it is showing? Sorry. Ammeter reading it is showing as voltmeter reading it is showing as voltmeter is the right one. 0.603, and then current value is 9.397. Okay, and the resistance value is 0.06. We got the resistance value. Next we change the rheostat resistance. Okay, I am keeping the resistance at here. You move it here like this. Okay, next voltmeter reading I am taking. Next reading 0.006, here 9.397. Then again you will get a 0.06. You change the values like this. Now we will change this one. For example, here the reading it is showing as voltmeter reading is 0.049. You write in this 0.049, and ammeter reading you take here 0.7 0.765. 0.049, 0.765, 0.049, 0.765. Like this again we find out the resistance at here. Like this 5-6 times you have to find out the resistance, then you have to find out the average. That is the value of the resistance, and also draw the graph between the V versus I. This is about one practical. And I will give from this some Viva voice also. You can see there is a in the in the Google there is OLAB is there. OLAB, you can search the OLAB and you can also do the practical. And there are some Viva questions are there. These Viva you see here, Viva questions. These Viva questions are useful for the exam. Okay, based on this practical also you will get the two marks. in the physics. Okay, there are only two practicals are there. Okay, one is Ohm's law and other one is prism practical. Okay, you see here, first one, which law explains the following? At constant temperature, current flowing through a conductor is directly proportional to the potential difference. What is this law? Write in the chat box, students. What is this law? Write in the chat box. Which law explains that current proportional to the potential difference? Which law it is? Ohm's law, Boyle's law, Joule's law, Charles' law. What is that? Write in the chat box. Next, what does the current through the wire depends on? Current on what factors it depends? Current formula is what? Potential difference by resistance I equal V by R according to Ohm's law. It depends upon potential difference and also depends upon the resistance, right? That means it is both resistance and potential difference because current formula V by R. Next one, you are measuring a current in the circuit operated on 18 volt. The ammeter reading is 40 milliamperes. And let us you notice that the current dropped to 20 milliamperes. How much has the how much has voltage changed? Okay, when voltage is 18 volts, current is 40. When current changed to 20, then what is the voltage? V proportional to I formula is there. Okay, V proportional to I formula is there. Then from that V1 by V2 is equal to I1 by I2 formula you can use. Then by using that you can solve potential difference versus current graph. Okay, for the linear resistor, it's a straight line, right? Then like this you can also answer these questions. What is the formula for the potential according to Ohm's law, which is correct? V by I is equal to R. First one is correct, na? Like this you can answer. It is very easy. Okay, right? There are some questions. For today's class, I am going to close. Thank you to all. If you have any query, you can ask me. Yes, the first option is the Ohm's law, right? Can you tell the second one? What does the current flowing through a wire depends? Current flowing through a wire depends upon what factors? Resistance of the wire, only resistance, or resistance and potential difference, only potential difference, or only thickness of the wire. Can you write? You write like this, you submit it here. Okay, at the end after this 10 questions, there is a submit button is there. If you submit, then it will give the correct answer also. If you have any query at the moment, you can ask. This is available in olab. You can search in the Google olab. Okay, you select the physics and you can go for the experiment Ohm's law and you write the viva question answers. Based on this one question they will ask in the exam. One or two questions, not only one, sometimes two, three also. Right? Okay. Both resistance and potential difference. Very good. Next, third question you can answer, Savan. Okay, first one is Ohm's law. We can click it here. Second one is the both resistance and potential difference. Third one, oh, Second one is the both resistance and next third one you have to use the pen. Okay. Here what happened? Current become half. What happens to the potential difference? It will also become half. Voltage changed. How much voltage changed? It will also become half because V proportional to I. We can write 9 volt. Is it right? What is the shape of the potential difference versus current graph? Straight line because V proportional to I. Potential difference by current is the resistance. Next, what is the potential difference required to pass the 5 ampere current through a metal conductor of resistance 10 ohm? You see here potential difference we have to find out current degree resistance degree equal to IR 5 into 10 50. Next, choose the statement of alternative. Choose the correct statement from alternatives. Every material has resistance. The resistance of the material independent of current passes through it. All of them is true. Resistance of the material is the measure how much it opposes the passage of free electrons. Choose the correct statement. Every material has resistance. Resistance of the material independent of resistance of the material is independent of current passing through it. All of them is true. Yes, all of them is true. Everything is correct. And the next, what is the resistor value? Here voltage they give, current they give. We have to find out the resistance. 26 by 13. You have to convert 13 milliamperes into amperes. Okay, 10 into the power of minus 3 we have to use. Milli to this milliampere converted into amperes. Resistance equal to V by I, 26 by 13 into 10 to the power of minus 3. You will get as 2 into 10 to the power of 3 ohms. That is nothing but 2 kilo ohms. And this color code resistivity of the gold wire. This is not in your syllabus. Okay. If the voltage across a fixed resistance is increased 5 times, what is the variation of the current? If voltage increases 5 times, then current also increases by a factor 5. Submit it. Now check the answers. You see here this right, and next one also right, next one also right, next one also right, next one also right, next one right. Okay, this one we not attempted because it is not in the syllabus, and the next one also right. Like this you can check. Okay, right. Thank you to all. Closing the lecture.